SwayamPrabha. Digital India. Educated India.
Welcome to lecture 40 of the course on multivariate data mining, methods and applications. The title of this lecture is Plaid Models for Block Clustering. In the last lecture, we have discussed bi-clustering and block clustering. Then we have also used two-way ANOVA for the block clustering. Plaid model is also a form of two-way ANOVA model. In Plaid model based block clustering, an item may be clustered into more than one groups. So, there is possibility of overlap between different clusters. So, in this lecture, we will discuss the clustering based on Plaid model. The Plaid models provide generalization of bi-clustering. Further, the Plaid models are a form of two-sided cluster analysis, that is bi-clustering, that allows clusters to overlap. So, this is where the Plaid models are different from other bi-clustering methods which do not allow overlap. Then the Plaid models incorporate additive two-way ANOVA models within the two-sided clusters. And using these models, we go for clustering. Then each layer is formed by a subset of rows and columns, and it can be viewed as a two-way clustering of elements of the data matrix. So, we are clustering along the rows as well as along the columns, and ultimately your cluster or each layer is formed by a subset of rows and columns. Then it has several applications. One of the application is the search for interpretable biological structure in gene expression microarray data. In gene expression microarray data, when we apply the bi-clustering or when we think of the bi-clustering, it may happen that a particular gene may belong to more than one clusters or more than one layers. So, the genes can be members of different layers or of none of them. This is also possible. Say, in usual clustering methods, each and every item is a member of some cluster. But here it may happen that a particular item is not a member of any cluster or any layer. Then overlapping clusters are allowed. The sums of layers are then fitted to gene expression data. It also allows a cluster of genes to be defined for only a subset of samples, not necessarily for all of them. So, we have a subset of sample, and then for subset of sample, that particular subset of sample, we have a cluster of genes. and this cluster of genes express in a similar way for this particular subset of samples. For other subsets or for other samples out of this subset, this cluster of genes may not express in a similar way. Now, for instance, certain yeast genes may cluster together based on their expression patterns during spore formation. So, you have a group of yeast genes. During spore formation, this particular group of yeast genes have similar kind of expression patterns. So, this particular group of yeast genes, a cluster is formed, but not during all the periods, just during spore formation, and clustering differently under other conditions. So, under other conditions, the yeast genes are clustering differently, and in such situations, if you want to apply by clustering, the Plaid models can help in identifying and characterizing these condition specific gene clusters. So, actually such kind of clusters are condition specific. Just during the spore formation, you are getting a cluster of yeast genes. So, this cluster is a condition specific gene cluster. Now, we consider the Plaid model. So, we consider this simple Plaid model, Xij equal to mu naught plus summation small k equal to 1 to capital K, mu k, rho I k, kappa j k. Here mu naught is the expression level of background layer. It is just like the general mean effect in ANOVA model. Then mu k is the expression level of the kth layer, and rho I k and kappa j k are 1 if the subscripts are equal and 0 otherwise. It means that rho I k equal to 1 in the presence of ith gene in the kth layer. Further, kappa j k is equal to 1 in the presence of jth sample in the kth layer. Again, if mu k is greater than 0, the expression level is upgraded. Say, here you have mu k, and if mu k is positive, then expression level, that is Xij, is upgraded. It is more than the expression level of background layer, whereas if mu k is less than 0, then the expression level is downgraded. Now, if summation over k, rho I k is equal to 1 for all I, and summation over k, kappa j k is equal to 1 for all j, it means that no overlapping is allowed. Notice that these rho I k's are either 1 or 0. Now, if summation over k, rho I k, that is, if we add rho I k over all possible clusters, if this summation is 1, it means rho I k is equal to 1 just for one cluster. Means this I is present in just one cluster. Similarly for kappa jk also. So in that case, no overlapping is allowed. And to allow for overlapping, we use the constraint summation over k rho I k is greater than or equal to 2 and summation over k kappa jk is greater than or equal to 2. So if summation k rho I k is greater than or equal to 2, suppose this summation is equal to 3, then there is overlapping in 3 clusters. That is, xi is present in 3 clusters. Further, a general ANOVA type Plaid model is, say, xij equal to mu naught plus summation over k mu k plus alpha I k plus beta j k into rho I k kappa j k plus, of course, you have error term here epsilon I j. So, epsilon I j is the error term, alpha I k is the effect of ith gene in the kth layer, and beta jk is the effect of jth sample in the kth layer. And we assume that summation over I rho I k alpha I k is equal to summation over j kappa j k beta j k equal to 0. It means if we take the effect of ith gene in the kth layer and then we add over all values of I, notice that rho I k is equal to 1 only when the ith gene is present in the kth layer. So, we are considering this summation only for those layers in which the ith gene is present. Similarly, here beta jk, we are multiplying it by kappa jk, and kappa jk is equal to 1 only when the jth sample is present in the kth layer. So, we are adding the effect of jth sample only for those layers in which it is present, the jth sample is present, and we take the summation equal to 0. Now, suppose theta I j k is equal to mu k plus alpha I k plus beta j k for k equal to 1 to capital K. Then we can write the Plaid model as xij equal to theta I j naught plus summation k equal to 1 to capital K theta I j k rho I k kappa j k plus epsilon I j. And then your problem is to estimate the parameters theta I j k. And for that purpose, we use the method of least squares. We minimize q equal to 1 upon 2 summation I equal to 1 to r summation j equal to 1 to n epsilon I j square with respect to theta I j k, rho I k and kappa j k. And we can write this q as 1 upon 2 summation over I summation over j xij minus theta I j naught minus summation over k theta I j k rho I k kappa j k whole square. So, this term. Here rho ik and kappa jk are either 0 or 1. Now, in all there are 2 to the power r minus 1 into 2 to the power n minus 1 possible combinations of genes and samples, as each gene and each sample can be in or out of each layer. So, either a particular gene belongs to a particular layer or not. Similarly, a particular sample belongs to a particular layer or not. So, the optimization problem is computationally infeasible, and we use an iterative process, adding one layer at a time. We just add the layers one by one. Now, suppose k minus 1 layers are already fitted and kth layer is identified by minimizing q. Then the residual remaining after the first k minus 1 layers is epsilon I j dash, we denote it by epsilon I j dash, equal to x I j minus theta I j naught minus summation I equal to 1 to k minus 1. It is based on first k minus 1 layers, theta I j k rho I k kappa j k. And then the value of q is 1 upon 2 summation over I summation over j epsilon I j dash minus theta I j k rho I k kappa j k whole square. And then we substitute the value of theta I j k here, which is mu k plus alpha I k plus beta j k, and then we have rho I k kappa j k here. Now, we have to minimize this q subject to the identifying conditions, say summation over I rho I k square alpha I k equal to 0 and summation over j kappa j k square beta j k equal to 0. Now, we use the method of Lagrange's multipliers. Actually, we have to minimize q subject to these restrictions. So, that is why we are using the method of Lagrange's multipliers. In Q, we involve these constraints using the Lagrange's multipliers. And then we differentiate with respect to, say, mu k. When we differentiate with respect to mu k, we obtain summation over I, summation over j, epsilon I j dash minus mu k minus alpha I k minus beta j k, and since we are differentiating with respect to mu k, so we get this term again here rho I k kappa j k, and we put it equal to 0. And then notice that summation over I alpha I k rho I k is equal to 0 and summation over j beta j k kappa j k is equal to 0. So, ultimately we obtain mu k star, which is the value of mu k which minimizes q subject to these restrictions, is equal to summation over I summation over j epsilon I j dash into rho I k rho j k divided by summation over I rho I k square. In fact, you get rho ik square rho kappa jk square here. 1 rho ik, 1 kappa jk is already there, and when we differentiate with respect to mu k, we get one more rho ik and kappa jk. So, we get summation over I rho ik square and summation over j kappa jk square here. Similarly, we differentiate with respect to alpha ik, this term. So, what we get? We get alpha ik star equal to summation over j epsilon ij dash minus mu k rho ik kappa jk into kappa jk divided by rho ik summation over j kappa jk square. Further, we get beta jk star equal to summation over I epsilon ij dash minus mu k rho ik kappa jk into rho ik divided by kappa jk summation over I rho ik square. In fact, we get these values when we differentiate q with respect to alpha ik, put it equal to 0 and then we solve it for alpha ik, and when we differentiate it with respect to beta jk, put the differential coefficient equal to 0 and then we solve it for beta jk. Now, given the values of rho ik s minus 1 and kappa jk s minus 1 from the s minus 1th iteration, we use these relations to update theta ijk s and at the sth iteration. Further, given theta ijk, for obtaining the updated formulas for rho ik and kappa jk, we differentiate q with respect to rho ik and kappa jk, set it equal to 0 and then we solve. Now, this is the value of q. We differentiate it with respect to rho ik, this, and then we set it equal to 0 and then we solve the equation for rho ik, and ultimately we get this value of rho ik star equal to summation over j epsilon ij dash theta ijk kappa jk divided by summation over j theta ijk square kappa jk square. Similarly, if we differentiate q with respect to kappa jk and then we put the differential coefficient equal to 0 and solve it for kappa jk, we get this expression for kappa jk star. Now, we can proceed as follows. Say, set the initial values of all the rho s and kappa s in 0, 1. Say, you can set 0.5. Then, given the values of theta ijk s and kappa jk s minus 1, use column and row means to update rho ik s. Further, given the values of theta ijk s and rho ik s minus 1 from here, use grand mean to update kappa jk s, and then keep rho and kappa away from 0 and 1 early in the iteration process, but to force rho and kappa towards 0 and 1 late in the process. So, initially we keep rho and kappa away from 0 and 1, but as we proceed, as our iterative process proceeds, we force rho and kappa towards 0 and 1. Then at convergence, The estimated parameters for the kth layers are, say, mu hat k, alpha I k hat and beta j k hat for all k equal to 1 to capital K. So, we get all these estimated parameters. Then the absolute values of the row effects. This is the row effect, mu k hat plus alpha I k hat, and the column effects, say mu k hat plus beta j k hat. For the kth layer, say k equal to 1 to capital K, can each be ordered to show which genes and samples are more affected by biological conditions of that layer. So, we can order these row effects and column effects for the kth layer. Now, within the kth layer, genes are said to be upregulated or downgraded if mu hat k plus alpha I hat k is greater than 0 or if it is less than 0. For greater than 0 case, the genes are said to be upregulated, and for less than 0 case, these genes are said to be downgraded. Then the size or importance of the kth layer is measured by sum of squares, sigma square k equal to summation over I summation over j, rho ij star kappa jk star theta ijk square. So, this is the sum of squares, and a layer is accepted if sigma square k is significantly larger than what we would find in noise. So, if this sum of squares is significantly larger than the noise variance, then this particular layer is accepted. Then this particular quality can be used to choose the number of layers capital K. Say we choose a layer or we accept a layer if this sigma square k is significantly larger than the noise variance, and otherwise we don't choose this layer, and we use this particular phenomena for choosing different layers and finally for choosing the total number of layers capital K. Now we consider this example of Plaid model biclustering. We have applied the Plaid model for doing the biclustering of randomly generated data set. The data matrix has been generated from the normal distribution, and then we have used the Plaid model, and the algorithm which we have used for this purpose is BC Plaid. Now, this is a part of the data set which we have displayed here just for the demonstration purpose, and then we have applied the biclustering here. Now, here are different layers, and then obviously the 0th layer has all the rows and columns in it, and then we have this layer 1 here, and the rows and columns included in layer 1, layer 2, etc. Then the layer 0 has 100 rows and 50 columns, and it has degrees of freedoms 149. This is the sum of square and mean sum of square. And the first layer has 10 rows and 10 columns. It has degree of freedom 19. This is the sum of square and mean sum of square. In fact, it has identified just one cluster which has 10 rows and 10 columns. Then here is the heat map, and again the heat map has observations as rows and different features as different columns, and then it identifies a bicluster here. Now we consider this example of bicut yeast gene expression dataset. We have already considered this dataset for biclustering purpose in lecture 39 also, but here we are going to use the Plaid model for biclustering purpose. And the algorithm which we have used is BC Plaid. This dataset has been obtained from experiments measuring gene expression levels in yeast cells under various conditions or treatments. Further, the microarray data matrix is for 80 experiments, the expression levels of 419 probe sets over 70 conditions. So we perform the Plaid model by clustering. Then the algorithm models data matrices to a sum of layers. And then for fitting the model to data, we have used minimization of errors. Now, these are the results. We have the zeroth layer. Obviously, this zeroth layer has all the observations in it, all the observations as well as all the features. So entire data matrix. Then we have layer 1 here and layer 2 here. Then you have information about layer 3 here. And then here are different layers corresponding those columns, degrees of freedom, sum of squares, and mean sum of squares. So obviously the zeroth layer has all the rows and all the columns, that is 419 rows and 70 columns in it. The corresponding degree of freedom is 488. And then here is the sum of squares, 2194.56. And then we divide the sum of squares by the corresponding degrees of freedoms to obtain this mean sum of square 4.50. Then the layer 1 has 48 rows, 5 columns. The corresponding degree of freedom is 52. The sum of squares is 1815.53, and then again we divide the sum of squares by the degree of freedom to obtain the mean sum of square 34.91. And layer 2 has 74 rows and 4 columns, and then the corresponding degree of freedom is 77, and then sum of square is 1288.94, and just by dividing the sum of square by corresponding degree of freedom, we obtain the mean sum of square as 16.74. Now this is the heat map, and as earlier, the rows and columns represent different observations and different features, and then just by looking at the heat map, you can identify different biclusters.
here or here.
So, in this lecture, we have discussed Plaid model. Plaid model is also a form of two-way model within two-sided clusters. In Plaid models, each cluster is formed by a subset of rows and subset of columns, or subset of features and the subset of samples. The difference between Plaid model and the bi-clustering procedures which we have studied in previous lecture is that the Plaid model allows a particular observation to belong to different layers, more than one layers. Here different layers denote different clusters. So, a particular observation may belong to more than one layers or more than one clusters, and it may also happen that it does not belong to any of the layers or any of the clusters. So, this is the beauty of bi-clustering, which is based on Plaid models. One of the important application of Plaid models based bi-clustering is gene expression data. In gene expression data, it may happen that a particular gene may belong to more than one clusters or more than one layers, or it may not belong to any of the clusters. Say, for example, in yeast gene expression data, you may find some of the genes which may express under certain conditions. So, under those group of conditions or under those conditions, these genes form a group or form a cluster. But under other conditions, these genes do not express in a similar way. So, these genes do not form a cluster. So, again, to observe or identify such kind of phenomena, one requires Plaid models based by clustering. Now, this lecture is the last lecture of data mining course. So, this course is going to finish with this lecture. In this 40 lectures course, I have tried to cover different aspects, different tools of data mining. The tools which I have covered include principal component analysis, which is a crucial method for dimensionality reduction. If you have high dimensional data and you are facing the curse of dimensionality, then to reduce the dimension of the data without losing much information, you can go for principal component analysis. Then we have discussed various clustering methods, including hierarchical clustering or k-mean clustering, or even bi-clustering or block clustering, which we have discussed in this lecture. So, the basic idea behind clustering is to segregate or to group the observations into different clusters so that the observations of a particular cluster follow similar kind of pattern. Then we have discussed different models of artificial neural network, including single layer perceptron, multi-layer perceptron, convolution neural network, and recurrent neural network. These models can be used to handle different kind of problems. Say, suppose you are using multiple linear regression model, then if the relationship between input variables and response variables is non-linear, then you won't be able to use this model. And if even the form of the relationship is unknown and the relationship is very complex, then one can go for multi-layer perceptron. And once you train the model, once you train the multi-layer perceptron for a given input variable, you can predict the output variable. We have also discussed the blind source separation problem, which is also known as the cocktail party problem. In fact, the factor analysis plays a crucial role in solving blind source separation problem. Then another classifier which we have discussed is support vector machine. Then classification and regression trees can also be used for classifying the observations into different classes as well as for regression problems. So, in this course we have discussed all these topics. Although several of the important topics which should have been covered during the course I could not cover because of the limitation of time. But once you have some basic idea of all these tools, then you can even study other tools also. All the tools are also explained by using some examples, and in most of the examples I have used R software for getting the solution. Of course, at many places, those who don't have very strong background of matrix algebra or mathematics or even strong background of statistics may have some difficulty. But still I feel that this course is quite useful even for applied workers who do not have very strong background of all these subjects like mathematics or matrix algebra or statistics. As I mentioned in the first lecture also, the scope of data mining is increasing day by day. In fact, in various fields, we are getting big data, and the kind of information or the kind of questions about the data in which one may be interested may not be answered using the classical statistical techniques. I had also given several examples in the first lecture where one has to identify the outlier or one has to identify complex pattern present in the big data. So, to solve such kind of problems, you require different data mining tools. Further, if you have big data and as a statistician, you think that you can use some of the sampling techniques to reduce the data size, and then you make inferences on the basis of sample about the population. Then this approach may not work in many areas. In fact, say suppose you are interested in some outlying observations, or you want to identify some hidden pattern in the data which is quite complex, or you want to answer some questions which involves local phenomena. In such cases, if you go for sampling, then you may lose some important information. Say your outlier may not be the part of your sample. So you are interested in having information about the outlier, but it is very likely that you won't get the information if you adopt sampling. So in that case, one should go for analyzing the entire data set. You don't have any option, and then one can use different data mining tools which are just meant for handling big data. I also advise you to apply all these tools to real world problems of your field, whether you are working in bioinformatics or you are working in the area of finance or management or any other field. Definitely you are getting big data in your field, so you just try to apply all these tools for analyzing the data. Further, while selecting a particular tool for your problem, you must keep in your mind what are the objectives of your problem, or for what purpose you want to tackle that problem. So whether that particular tool is going to serve your purpose or not. Further, you also remember that being expert in data mining also requires to be expert in some software using which you can analyze your data and you can apply different data mining tools. So be prepared for that and try to be expert in some of the statistical software using which you can apply different data mining tools. Hope you have enjoyed this course and you will be benefited by the different topics which I have covered during the course. I am going to stop here. Thank you.
Hi, I'm Chitwan Lalji, a PhD student of Health Economics under the supervision of Dr. Debayan Pakrashi from the Department of Humanities and Social Sciences, IIT Kanpur. In one of my essays, I'm interested in understanding the relationship between consumption of fruits and vegetables and various health indicators. Health indicators, both subjective and objective health indicators like mental health, self-assessed health, various measures of blood pressure and various measures of cholesterol. Measures of blood pressure like systolic and diastolic BP. You have your incidence of high BP, MAP and incidence of high MAP. And as far as cholesterol is concerned, I have tried to concentrate more on total cholesterol, good cholesterol and incidence of high cholesterol. Now before I go on to what have been my major contributions and various policy implications, I would like to briefly tell you about the policy initiatives of WHO and various countries. The WHO, that is the World Health Organization, it started with a campaign of 5 a day. That is, you should have 5 portions of fruits and vegetables per day. That would be approximately, you could say, 400 grams of fruits and vegetables. Now, a portion, before we go further, I'll just tell you what exactly is a portion. One portion is equivalent to a medium-sized apple, or one small glass of fruit juice, which is approximately 150 milliliters, and maybe 3 teaspoons of vegetables. So, the WHO went with the 5 a day campaign, which was further taken up by various countries. Countries like UK, Netherlands, Germany, Norway, they adopted the 5 a day policy, while some went for expansionary dietary policies like France, Australia, Canada, Denmark. So, for example, Australia, it went for 2+5 policy, in which it said that you should consume 2 portions of fruits and 5 portions of vegetables per day. And USA went for a policy of fruits and vegetables more matters. That is, you must consume more and more fruits and vegetables. Now, irrespective of these expansionary dietary policies and dietary propagations, it has been found that only 28% of women and 25% of men, they actually meet the recommended dietary norms of 5 a day portion. So, the major contribution of my work is firstly to find an association between fruits and vegetables, whether there exists a relationship between fruits and vegetables and health indicators, and if they exist, whether due to heterogeneity in the data. So, I will be doing it according to age, by gender and by your weight. So, apart from that, I will go for policy recommendations, in which I am basically studying how much fruits and vegetables matter. Apart from that, which type matters more. So, for that, I have taken data from the Health Survey of England. Health Survey of England is an annual survey which takes data, which conducts information regularly on demographic and socioeconomic characteristics. You have your lifestyle behaviors like an individual smokes or doesn't smoke, alcohol consumption, you have your sedentary and physical activities, and you have various health indicators also which have been collected. Before I go on to what exactly is my research, I would like to concentrate more on fruits and vegetables, like what kind of questions were asked in the survey. Questions like, what kind of fresh fruit do you eat? Did you eat any dried fruit yesterday? Don't count dried fruits in cereals, cakes. Apart from that, for vegetables, they asked how many tablespoons of vegetables did you eat yesterday? So, approximately after this whole survey was conducted, data was converted into portions of fruits, and like for example, 3 tablespoons of vegetables is equivalent to 1 portion. So, data was converted and provided to the users, that is us, from the UK Data Health Survey. So, the major contributions of my paper is that I found a strong negative association between intake of fruits and self-assessed health, then various measures of blood pressure like mean arterial pressure, high blood pressure, systolic and diastolic BP, and your total cholesterol. Apart from that, I have found a strong positive association between consumption of vegetables and good cholesterol. So, it is recommended in a way that if you want to control your blood pressure, you must consume more and more fruits. And as far as vegetables are concerned, they impact your good cholesterol. Apart from that, I went in for a falsification test. A falsification test is basically conducted to know whether the model that you have adopted and the conclusions that you are drawing are not spurious. So, if a falsification test is done to know, in a way it is tested by seeing an indicator, a health indicator which is not being impacted by your consumption of fruits and vegetables, and then we see whether there is significant result or not. If there is no significant result, that means your model is good and your results are non-spurious. So what we did is, for falsification test, we took ear complaints and infectious diseases. Now ear complaints, like if you are deaf since birth or you have some kind of imbalance, body imbalance, that is not being impacted by your consumption of fruits and vegetables, and we did find insignificant results. Apart from that, infectious diseases like HIV, AIDS, etc., we found similar insignificant results, indicating that our results are not non-spurious. Apart from that, we went, since there was a lot of heterogeneity in the data, like by gender, by age and by weight, we did the regression analysis. We found results which stated that as far as fruits are concerned, it impacts a male's health more than a female's health. So it is basically said a man should consume more fruits to impact his health, whereas as far as vegetables are concerned, they impact a women's health more. But this has been only seen as far as cholesterol is concerned, the various measures of cholesterol like total cholesterol, good cholesterol and your incidence of getting high cholesterol. Now after this, we went in for a policy implication, and in the policy implication we tried to find two policy implications: what matters and exactly how much portion matters. So as far as how much portion matters, we have found that on an average 5 or more portions of fruits impact your overall health, that is your self-assessed health, your MAP, your incidence of high MAP and incidence of high BP. But if you want to have a good mental health, so you can optimize your mental health by consuming 3 or 4 portions of fruits as well. And similarly, as far as self-assessed health and total cholesterol is concerned, an individual must consume 4 to 5 portions to optimally have the impact of consumption of fruits. Apart from that, vegetables have had a very little impact on your health. It only impacts your incidence of getting high MAP and high BP, and it's seen that only it impacts when you consume 5 or more portions of fruits. So an optimum consumption of 5 or more portions of fruits and vegetables are recommended, but fruits have a more impact on your overall health, on various measures like self-assessed health, mental health, your various measures of blood pressure and various cholesterol levels. Another thing that we find is which type of fruit matters. It has been seen that all size fruits, they impact your self-assessed health, your systolic and diastolic blood pressure, your mean arterial pressure, your high BP and incidence of getting high MAP and high cholesterol. But we find that as far as frozen fruits or canned fruits are concerned, they help in regulating your incidence of getting high MAP or high BP, but it has a trade-off. That means there is something negative happening. It reduces the good cholesterol in your body. Apart from this, if you have an incidence of getting high cholesterol, it is recommended that you must consume fruit juices, because it has a impact in reducing your probability of getting high cholesterol. And dried fruits, they impact your self-assessed health. As far as vegetables are concerned, very little impact has been seen. It has only been seen in case of portion of salads and its association with self-assessed health. Another thing that they have seen is vegetables in composite, they have an association with good cholesterol. So overall, my research basically says that there is an association between consumption of fruits and vegetables and various health indicators, and it is highly recommended that an individual, in order to be healthy, must consume 5 or more portions of fruits and 5 or more portions of vegetables per day, but fruits have a more impact on your overall health. Apart from that, all size fruits, they have a better impact on your overall health, your mental health, various measures of blood pressure and cholesterol. So, thank you.